Hi, welcome to Math 1300, Nunez Community College. This section is section 4.1, which is quadratic functions. Quadratic functions. What is a quadratic function? Well, a quadratic function is going to be in the form of x to the second power. X to the second power. A quadratic function makes a very special shape. It's called a parabola. It makes a parabola. A parabola looks basically like a U, either a U or an upside down U. So it would look like this if it's facing up, or this if it's facing down. That's examples of parabolas. A parabola is going to have a vertex, which is basically the point at which the parabola opens. And if it faces up, then this vertex is the lowest point or a minimum point on the graph. Or if it opens down, then this point, which is also the vertex, is called a maximum point or the highest point on the graph. So what I want to do today, or what we want to do today, is we want to look at the different equations for a parabola or for a quadratic function. The first one we're going to have is going to be called the standard form. The first one we got is called the standard form. The standard form of a parabola. And it's going to be f of x is equal to a times x minus b squared plus k. Or yes, that's what they used. So what we're going to do here is we're going to have a, b, and k represented by numbers. And the most important thing that we find is the vertex. Because again, the vertex is basically the center of the parabola. It tells us a lot. So the vertex that we're going to find is going to be easy. All we do is pick out the letters. The vertex is going to be b, comma, k. B, comma, k. With b being the opposite of what you see in the actual equation or the function, and k being the same as what you see in the function. So on an example number 1, we have f of x is equal to 2 times x minus 3 squared, 2 times x minus 3 squared plus 5. And they want us to find the vertex of the parabola. Find the vertex of the parabola. So what we have is the opposite of b, so the opposite of negative 3, which is 3, comma, k, which is 5. The vertex for this parabola would be 3, comma, 5. Another one we have, f of x is equal to negative 3 times x plus 2 squared, negative 3 times x plus 2 squared plus 4. Again, we want to find the vertex. The vertex here is going to be the opposite of the b, so it's going to be negative 2, comma, 4. So that's how we find the vertex if we're in the standard form of a quadratic function. The next thing that we're going to look at is we're going to look at opens. Opens means, does it open facing up or does it open facing down? So opens deals with the letter A, which is in front. If A is positive, then the parabola opens up, which means it looks like this. We would have our vertex we would find, and we would see that it opens up with the arrows facing up. If A is negative, then the parabola opens down. So it would look like this. So far we can find the vertex, the opposite of b, comma, k, and we can tell which way the parabola opens, whether it opens up or it opens down. For this one that we have here, the opening, it opens up because 2 is positive. A is positive. This one here opens down because the 3 is negative, the A is negative. What we want to eventually do is we want to graph these quadratic functions. We want to graph the quadratic functions. The vertex is the most important thing because that tells us the location of where it is, where the origin is. And then opening up or down tells us the general form of what we should have. We also have a couple of other things that we're going to use in order to aid us in graphing them. Let's look at one and we'll go over that in a second. So we got example number 2. It says f of x is equal to 2 times x plus 1. F of x is equal to 2 times x plus 1 squared minus 8. Minus 8. So step 1 opens. And for this one here, we can see that it's a positive 2, so we know it opens up. Okay, so it should look like this when we're done. Step 2 is the vertex. And the vertex in this one, the opposite. So negative 1, comma, k, what we see, which is negative 8. So the vertex is negative 1, negative 8. So with this step, we're going to go over to our coordinate plane and we're going to graph what we know so far. So at negative 1, negative 8, this is our vertex. And we're going to label it negative 1, negative 8. Okay, negative 1, negative 8. And we know it's opening up, so we know it's going in the upward direction. Well, other things that we're going to use to aid us is going to be, if it's opening up, it's got to cross the x-axis. So we're going to find for step 3, we're going to find the x-intercepts. So where it crosses the x-axis is called our x-intercepts. And we know from, if this thing opening up, any number on the x-axis has a coordinate, and that coordinate is some number for the x, but the y is 0. For instance, if this was our number, this would be 1, 2, 3, 4. This would be 4, comma 0. So I know the x would be 4, and the function itself, or the y, would be 0. So in order to find the x-intercepts, we set the equation equal to 0. We make the y 0, and then we solve. That will allow us to find the x-intercepts. So I make the equation equal to 0. 2 times x plus 1 squared minus 8 equals 0. And then we solve. So from here, I have what? X plus 1 squared. I'm going to do that first. I would what? FOIL it. So that would be x plus 1 times x plus 1, which would give me what? X squared plus x plus x plus 1. First, outside, inside, and last. Now I can combine these two. That would give me x squared plus 2x plus 1. So this is the product of x plus 1 times x plus 1. So I'm going to replace this with what I just did. That's going to be 2 times x squared plus 2x plus 1 minus 8 equals 0. So now I'm going to distribute the 2. So I have what? 2x squared plus 4x plus 2 minus 8 equals 0. And then what? Collect my like terms here. 2x squared plus 4x plus 2 plus minus 6 equals 0. Now I can what? I can factor out a 2, because all of them have a 2 in it, giving me 2 times x squared plus 2x minus 3 equals 0. And now factor this, giving me x and 3 and 1 and plus and minus, because I need numbers that multiply to give me -3 but add to give me -2. Therefore, x equals -3 and x equals +1. So my x-intercepts are -3 and +1. So at -3, we cross the x-axis, and at +1, we cross the x-axis. Now, one thing we know about the parabolas is they're symmetrical. So through the vertex, it opens like a book. So if I went over 2 units to the left to cross the x-axis here, I would go over 2 units to the right to cross the x-axis there. There's another step that we're going to take, because there's also going to be crossing the y-axis. We're also going to cross the y-axis. And from the looks of it, if I'm going up and getting to this point, I'm going to cross the y-axis somewhere in this area. So we have a step 4, which is the y-intercept. The y-intercept. And just like this, where I know that these numbers are 1, 0 and -3, 0, where the y values are 0, because it crosses the x-axis, I know wherever it crosses the y-axis, the x value is 0. So for this one here, we set x equal to 0 and solve. Set x equal to 0 and solve. So I'm going to have f of x is what I'm trying to find, is equal to 2 times 1 squared minus 8, because I'm setting the x equal to 0. So I got what? 1 squared is 1 times 2, so I got 2 minus 8, which is -6. F of x is equal to -6, which means y is equal to -6. So at -6, we would cross the y-axis. It would be 0, -6. And then we would draw using the intercepts that we have as our aids. So it would go up through here and go up. This would be the graph. Again, we're looking at the vertex. This vertex happens to be on the bottom because it opens up, so it's the lowest point on the graph. We would then find in the x-intercepts and the y-intercept. Now, not all of them have an x-intercept. Suppose I was doing one and the vertex was, let's just say here, because the vertex can be anywhere, but it's still opened up. If this happens and it still opens up, but it's above the x-axis, there will be no x-intercepts. And again, when you're trying to solve it, you would not be able to factor. You would come up with an imaginary number if we were doing this. If that happens, then check it out and make sure that it has no x-intercepts. Another form of a quadratic equation that we have is called the general form. So this is the standard form. We also have a general form. In a general form, we have f of x is equal to ax squared plus bx plus c, where a, b, and c are numbers. The general form is what you use more when you were in a lesser class, like in Algebra 2 in high school. We would have probably used the general form a lot. So let's look at the differences in what we have here. In a general form, we also need to know which way it opens. And just like in the standard form, we look at the letter A, and if A is positive, it opens up, and if A is negative, it opens down. Same thing happens for the general form. Positive A opens up, and negative A opens down. Same exact thing. We look at the A, the first letter. Step 2, well, we have to find the vertex. And the vertex in the standard form is negative B, or the opposite of B, comma K. It's very easy, you just look at it. In the general form, it's a formula. We have negative B, opposite of B, negative B over 2A. Negative B over 2A. So the opposite of B over 2 times A. That gives me my X portion of the coordinate. It gives me my X portion of the vertex of the parabola. In order to find the Y portion, we take whatever number we have here and we plug it into the X's, and that gives me the Y. This represented looks like this. F of negative B over 2A. Which means whatever number we get here, we find F of that number, meaning we put the number in for X's, and that gives me my Y portion of the vertex. Y portion of the vertex. Step 3, exactly the same. We find the x-intercepts, and to find the x-intercepts, we set f of x equal to 0 and solve. And then step 4, we find the y-intercept. And again, just like the other one, they may or may not be x-intercepts, okay? And then for step 4, we find the y-intercept. We set x equal to 0 and solve. So we literally plug 0 in for our x's and we solve. So let's look at an example that has a general form. The first part of it says, just find the vertex. So I have f of x is equal to negative 2x squared. F of x is equal to negative 2x squared plus 12x minus 16. Plus 12x minus 16. And they want us to find the vertex. They want us to find the vertex. So first part, opens. We look at it, A is negative, so opens down. That's just for our own knowledge. Second part, we want to find the vertex, because that's really what they're asking for this question. So it's going to be negative b over 2a. So negative b is going to be what? Negative 12 over 2 times negative 2. This is going to be 4, so negative 12 over negative 4 is positive 3. Positive 3. Once we find that x is positive 3, now we're going to find f of negative b over 2a. So now we're going to find f of 3. Whatever number we get for this is what we plug in there. Whatever number we get for this is what we plug in there. So I'm going to find f of 3, meaning I'm going to plug 3 into the x's and see what we get for our y. So I'm going to take negative 2 times 3 squared plus 12 times 3 minus 16. That's going to be what? 9. That's going to be negative 18 plus 36 minus 16. So that's going to be what? 36 minus 12, what's 34? Which should be 2. So 3 comma 2 should be our vertex. 3 comma 2 should be our vertex. Okay, now what we're going to do is we are going to do the whole thing. We're going to take another one, we're going to see which way it opens, find the vertex, and we're going to graph the whole thing. So the one that they're going to have for us is going to be f of x. By the way, this is example number 4. F of x is equal to negative 2x squared. F of x is equal to negative 2x squared minus 5x plus 3. Minus 5x plus 3. For this one, we're going to figure out which way it opens. A is negative, so it opens down. We're going to find our vertex. Our vertex is going to be negative b over 2a. So we have what? Positive 5 over 2 times negative 2. So that's going to be what? That's going to be negative 5 over 4. Negative 5/4. And then we are going to, oh, that's negative 5/4 is in the x position. And we're going to find f of negative 5/4. So what I'm going to do is I'm going to plug in negative 5/4 for x's on both. So we have negative 2 times negative 5/4 squared minus 5 times negative 5/4 plus 3. So that's going to be negative 2 times what? 25 over 16 minus, well, in this case it's plus because we have negative 5 times negative 5. So 25 over 4 plus 3. Here we can cancel the 2 and the 16, making that an 8. So that's negative 25 over 8 plus 25 over 4 plus 3. Which we need to have common denominators in order to add them. The common denominator here between 8, 4, and 1 is an 8. So that's negative 25/8 plus, this is 50/8 because I have to multiply by 2 to get an 8, plus this is what, 24/8, which gives me a total of 49/8. So 49/8 is going to be my y coordinate of vertex. This is not a very good one to be able to graph, but we'll look at it and see what we can do. So I have my coordinate plane. I'm at negative 5/4. Negative 5/4 is basically negative 1 1/4. Okay, so about right here, and positive 49/8. We'll put it up here, positive 49/8, which is about what, 6 1/8. So we have negative 5/4 and positive 49/8. It's opening down, so it will hit the x-axis. And we will have a y-intercept. So for step 3, the x-intercept, we are going to what? We are going to let it equal to 0 and solve. So I have negative 2x squared minus 5x plus 3 equals 0, and we're going to solve. Since we have a lead coefficient, and the lead coefficient is negative, I would prefer to just do the quadratic formula in order to solve it. You may or may not want to use something else like completing the square. So the quadratic formula, x equals negative b, so that's 5, plus or minus the square root of negative b squared, so that's going to be 25, minus 4 times a, which is negative 2, times c, which is 3, all over 2 times a, which is 2 times negative 2, which is negative 4. X is going to be 5 plus or minus the square root of 2 times 4 is 8, 8 times 3 is 24, so 25 minus 24 is 1. Oh, we're not subtracting, we're adding them because there's two negatives. 25 and 24 is what? 49 over negative 4. So now we're coming up with x equals 5 plus or minus the square root of 49 is 7 over negative 4. So that's going to be 5 plus 7 over negative 4 and 5 minus 7 over negative 4. So that gives me 12 over negative 4, which is negative 3. So x equals negative 3 for one of them. Negative 3. And 5 minus 7 is negative 2 over negative 4, which is positive 1/2. Which is positive 1/2. So our x-intercepts are going to be negative 3 and positive 1/2. And then finally, for step 4, which is the y-intercept, or in this case, step 4, which is the y-intercept, we're going to look at the equation. We're going to plug in zeros for our x's. If I plug in a 0, I got negative 2 times 0 squared minus 5 times 0 plus 3. These two both go away. 3 is the y-intercept. So at 3, we're crossing the y-intercept. I know this is not really 3 because I didn't go all the way up to where I should have, but we'll call that 0, 3. And therefore, this would be us graphing that parabola. This is us graphing the parabola. That is the last of the examples for this particular section. Remember, we need to go through the steps: opening, vertex, x-intercepts, and y-intercepts. The two forms we have is the standard form and the general form. Hopefully you can do your homework and everything will be good with that. Most of them will not come up to be fractions like this. Most of them will come up to be whole numbers, which should make it a little easier. All right, well, that concludes this section. I guess I'll see you at the next one.